Hello everyone and welcome to another hour of playful learning with the 2-Bit Circus Foundation. We are so excited to be here today. I am Dr. Dijanna and I'm here today with Rainbow Seal Girl. Say hello.
Hello.
And today we're inviting all of you to join us in this activity that's called what?
Top brick.
Yes, Top Brick. Today's activity is brought to you by Vans. We're so excited. We're having fun today. We're having fun. All right, so if you're joining us at home, go around the house, see what you can collect, what you can get to kind of maybe follow along on this activity. I want to remind all the parents and educators out there that this particular activity has been inspired by a project that you can find in the 2-Bit Circus Foundation's Brick Playbook. It's Project 23, and you can find it on page number 49. Now, before we get started, let's read off the materials list. You want to do that for me, Rainbow Seal Girl?
Sure.
All right.
You need assorted Lego bricks, especially, 4x4 plate and 2x2 bricks. You don't exactly need the plate, but you can use it. Paper, markers or pencil or pens or any other writing utensil. And if you're probably thinking top brick, it's not that top. It's like a spinning top.
Cool. All right. So let's do it, right? Mm-hmm. All right, you guys, let's go. We're going to change scenes here. You can see us. Hi. Hello.
Here's
good morning.
Our strawberry top, our mascot for today.
We have a mascot for today. We're super excited. We're here. We're gonna have some fun. So you'll notice that we have a beautiful design right here. Do you want to talk about this, Rainbow Seal Girl?
Yes. So I was drawing some tops and it turned out to look like a strawberry, but I wanted to build it, but that didn't turn out so well. These were my 2 attempts. Let me show you in the front. None of them looked like a strawberry. So it just turned out to be our mascot.
That's all right. The strawberry mascots are pretty cool. All right, so today's all about tops. I actually haven't played with a spinning top before, but when I talked to Rainbow Seal Girl, she was like, "Oh, I know exactly what a top is. Isn't that right?" She was like, she's played it, little game, the dreidel game, right? She's played that. It's
I don't really understand it though.
We don't understand how the game goes, but the dreidel spins, right?
Yeah.
Cool. So let's see if we can do some demonstrations here of.
Let's move our precious strawberry top off to the side. There.
All right, and why don't you give our top a little spin?
I honestly like this one better for some reason.
Go for it.
All right, let's try it out. Oh, hold on, let me try that again. Okay, why isn't this working?
Try again. And again.
That was better.
And again.
Let's try this one then. Into a basket.
Cool.
Well, we can see that this one was a little bit more successful. Let's try doing it at the same time.
Nice.
So they're both very successful.
Cool. So why? Let me see. Oh gosh! Did we break it? We keep doing that. Why do tops spin? Like if you get a good spin on it.
I don't know why it spins.
Let me see.
I kind of wish we had a real top.
It's kind of cool.
But these Lego ones are cool.
We made some out of Legos. We're going to be making a lot more out of Legos. We didn't have a real one, so we made some demonstration ones out of Legos. All right, so it's kind of cool. If you have a real one at home, they're so fun. You can just kind of... Okay, why isn't it... Wait. Okay, one more time. There we go.
It's better.
Oh, this side. This side's better.
It is better.
Oh! So cool. They spin.
Wait, what if we tried it on this side?
Okay, try. Kind of. Kind of. Cool. Well, the cool thing is that these toys are so much fun. We're gonna make a bunch of them out of Legos today. But the reason why they work, like it's physics, it's science, right?
Yeah, but I think I know why this side works so well.
Why?
It's because in this there isn't really a possible way it could tip over like that.
Oh, because it has a sturdy base.
Yes. So if you're wanting to make your own Lego top, make sure it's a little bit different than this, I guess.
All right, cool.
So I guess this is really the only sign that makes it fair. Because you can actually tip over.
I know, but I really like this. Is so cool. Okay, see that? Are you guys seeing that? It's really cool. All right, so why does it work? It's science, right?
I don't know why it works.
Science.
Cool.
So
could you tell me more about it?
A little bit about science? A little bit. So I'm going to break it down.
Or maybe a lot of it.
When it comes to things that are in motion, basically we're talking about physics, which is a really cool branch of science.
I haven't learned physics yet.
Oh, I can't wait for you to learn some physics. Physics is pretty much what gets those rocket ships to go up to space. Like, it's all based on physics. And a lot of physics have to do with this guy. This is a scientist back in the days. His name was Newton. You might have heard some stories about him. Newton came up with these laws because he observed how things were moving and how things were happening, and he came up with some observations that led to some laws. So the reason why the top spins is because of Newton's first law. Check that out.
Ooh.
All
Can
right.
I read it?
Go for it.
Newton's first law. An object in motion will remain in motion unless acted by an outside force or gravity, which is an outside force.
So you do know a little bit of physics. Okay, Rainbow Silk Girl just dropped the knowledge that gravity is a force.
Well,
that's right.
Yes.
That's cool.
For another example, if Earth didn't have any gravity, then we could literally be floating in the sky like we're flying.
Woo! Okay, float with me. Woo! All right. Thank goodness Earth has gravity. Gravity is a force. It's an invisible force. We can't actually see it, but lots of objects have gravity. That's the force that wants to pull you into the object. So Newton's first law says that an object's gonna be in motion. So if we send our top and we spin it, okay, let's do the better one, yeah?
Yes.
Why don't you give that a spin? I just broke it. All right, why don't you give that a spin?
Yeah,
for me?
but this one's not fair.
Just spin it. We're just spin it. Oh, okay.
Okay,
Oh.
now it's fair.
There we go. So it's going to stay in motion. Anything that you put in motion is going to stay in motion until it is acted on by another force.
Yeah.
And in this case, what force is stopping the motion of our spinning top?
Gravity or me touching it.
Yes.
So like if it's in
yes.
mid-spin, if I touch it, it just stops.
Okay.
Oh, and another reason, if we didn't have gravity, we could easily just like, if we just take one step, we could be flinged out into some random place.
I think that is the beginning of some sort of sci-fi novel that we should write. We should write a comic book about that
would be
for sure.
amazing.
A world without gravity, right?
That
That'd be
means
cool.
that you can walk on walls, walk on roofs,
Oh, that'd be
walk on the ceiling. Oh my god.
That sounds to me almost like a superpower. Like your superpower is to defy gravity. Whoa.
Now let's get back into the project.
Okay, back to the project. We had a little sideline. So that's cool. We figured out, Newton made this observation. Objects in motion, they're going to stay in motion until an outside force acts on them. In this case, we're saying that object's going to stay in motion until gravity sends it tumbling down. But there's something else acting on this particular object, and it happens on all objects that spin. It's super cool. So, ooh, did you just make a new one? Let's see. Okay, this one we're gonna need to improve. We'll do some iterations on that.
Not like that.
Okay. Oh, not too bad. Not too bad.
It's really thin.
It's trying to spin. So
Well, it's probably because it's heavier, so
Whoa.
gravity is it's easier for it to pull it down.
So she just added some more Lego bricks onto that spinning top, and she said it wasn't working as well, probably because it was a little bit more heavy or it had more mass. Great observation. We're gonna loop back into the science on that situation in a second. So far we've got, dude, these spinning tops are gonna work well for us because of Newton's first law. They're gonna spin until they stop because of gravity, but they're spinning. There's another force we need to talk about. Let's see. Will you read this one out? It's a little sciencey. I tried to simplify it the best I could. There we go. We've got something else going on.
Angular momentum.
Let's say it together. Angular momentum. All right.
Simplify.
I tried to simplify it. It's actually kind of quite complex, but let's see if the simplification works.
It is what you see when an object spins around instead of proceeding in a straight line. It depends on size, mass, and how fast an object spins.
Yes.
You
So
forgot N.
Oh, thank you for grammar police right there. Thank you very much for helping me out there. So it turns out okay, so we've got gravity, acting on our spinning tops, and we've got this thing, angular momentum, that has something to do with what?
Size, mass, and how fast an object spins.
Got it.
So like,
give us an example here.
Like if we added these two tops together. Oh my gosh, this is hard. I cannot connect these. Help me.
I gotcha.
Help me.
There we go.
That looks more like a rocket ship now.
Let's see what we got. Go ahead and give it a spin. Hopefully it doesn't spin all the way out of here.
The rocket ship spinning top.
Oh no. I totally foresaw that happening. While Rainbow Silk Girl is trying to retrieve the top, let me tell you a little bit more about the science. So now that you have all of your materials, hopefully you've had time to collect different Lego pieces and different whatnot, we want you to try and build a spinning top. Now remember, when you're building a spinning top, it's a battle. It's a battle between gravity, what makes the top stop and fall down. Oh, thank you for joining us. And angular momentum, okay? That's that spinning top's gonna wanna keep spinning and spinning. But the angular momentum depends on 3 things. Rainbow Silk Girl, do you remember what those 3 things are?
Size, mass, and how fast it spins.
Size, mass,
and one thing,
and how fast.
Big warning, do not make it too complicated like this strawberry top.
Oh, yes.
Do not make it too complicated like this strawberry top.
Yes, that was our initial design, and it was a little difficult to make a strawberry top, so we ended up with different things, but that's okay. We're gonna use whatever we have here. It's really fun and cool. So the challenge is to use Legos to make some spin tops. Should we do it?
Sure.
Keeping in mind
that mostly this one.
The way it spins is gonna be related to how heavy it is, its size, and how fast it spins. Shall we get to build it? Yeah?
I want to use this.
All right, let me remind you guys back home, if you haven't collected things, we pulled out a bunch of different Legos here. We pulled out some 1x2s, and we also pulled out...
I'm going to do the ultimate challenge. Well, not so
ultimate
though. An ultimate challenge is by using the whole entire base plate. But I'm going to use this.
Oh, awesome. We pulled out some base plates. If you have some base plates, go ahead and use those. We have some 2x2s that we pulled out right here. We have some random stuff that we just had around. And then we also have a bunch of other ones, some slides and some flats. So really assorted Legos. Flats are great to use.
Assorted Lego
And
bricks.
we're gonna attempt to make some more spinning tops. But we're gonna try and keep in mind that there's 3 things that matter when it comes to the angular momentum and how fast it's gonna spin. Oh my gosh, did you see her example she made right there? Look at that. Oh, that is so, can we time them? I think we should make a bunch of them and do a battle and figure out how much time they spend. That is so cool. And it spins right off screen, but you guys can see it on this camera over here. And you made that so quickly. So let's do it. Let's build together, yeah? And then test. We'll build and test.
Mine now.
I'm gonna build. Challenge. Let's build 2 each, and then we're gonna battle them out. Yeah?
I'm gonna go with my idea again.
All right. Let's see here. Let me get these guys here.
I'm gonna do
doing
the same thing
challenge
again. I'm doing the same thing again. Exactly the same.
Cool.
I want to see if it still works. So
All right.
you have an absolute challenge.
I do have a challenge here. Okay. So I'm gonna use. Why don't you share with them? Let's see if I can move the build plate up there so that you can build there, and share with them the things you're using. So you're using a flat
I'm
one.
using the same thing as I'm using as this.
Okay.
Except the thing is different. So I just need 1 block. My best orange 1 blocks. My besties.
Okay. Let's see here.
My besties. All right, I'm done.
You're already ready?
Are you doing the same thing as me?
No,
Don't you dare.
No,
copy.
I'm doing something different.
Now let's see if they both work.
Thing.
So we already know this one works pretty well. Now let's see this one.
Nice.
Okay, so I'm done.
Okay, now here's mine. I'm calling this one. This one is called the hat.
It does look like a hat.
The hat. Hold on a second. I'll turn this guy off. This one is called the hat. Let's see how this one goes. What's wrong with it? What should I increase?
I think you should decrease the weight.
Decrease the weight. And if I decrease the weight, you think that might increase its angular momentum?
Yeah, but I'm helping you, so that's 1 point off.
I get 1 point off? Oh my gosh. So here are my 2. Where are your 2? Bring your 2 out for the battle.
They're already out.
Okay, so we're going to time them.
Wait, so you're using the one we already made?
Shh. Yes. We're going to time them. So I have my phone right here. I'm going to put on a timer. You guys can time them too. But take your time if you're building at home. Go ahead and build them and test them out. Super fun.
Just enjoy.
Just enjoy. Timer activated.
Hey, not yet. Stopwatch.
Timer.
Hi.
Stopwatch. Okay. Are you
Mine
ready?
first.
You're going to go first. All right. Rainbow Seal Girl is going first. I wonder if some of our viewers might be on Team Rainbow Seal Girl and some of our viewers might be on Team Dr. Dijanna. We'll
Team
see.
Rainbow Seal
Before
Girl.
we get started, go ahead and give them a detailed tour of what you made and how you made it. And all
Okay,
the
well
different
yours
parts.
is gonna have to be really detailed. So what
Okay.
I did, I took
Oh.
this
Okay, go ahead.
weirdly shaped base plate and all, and so I added 2 little ones like this, like the one on one of our original designs, and then I added is it 2 by 2?
Mm-hmm.
Yeah, a 2 by 2 block on the bottom, and then I tried it out like this, upside down.
Okay.
Now start the timer.
Great. Oh, wait, hold on. My phone just locked. Let's get this going here. And your time starts now. And it fell off.
At 2 seconds.
One more time. We'll take an average. Wait, what's an average?
You don't know what an average is?
I want you to help tell the people at home. What's an
All right,
average?
so an average is exactly like it's almost like what's your average. Like if you're going on a treadmill or something, your like if it's say like your average running is, let's say, 1 mile per hour.
Okay. So the way you get the average, say you go for a run for an hour, it'll give you your average speed. So basically we're going to do multiple trials and divide them up and see what we get, yeah?
All right, so that was 2 seconds.
Okay. You ready for the next one? On your mark. Get set. Oh, wait. Lap. Let's do a lap. Go.
At 6 seconds this time.
Reset. I messed up. Try again. On your mark. Get set. Go. You guys, oh my gosh. Let's take some data. What am I doing here? I'm a scientist. Let's make some data so that we can officially keep track of what's going on. Do you agree?
Instead of doing laps.
Yes. So there's a sheet.
So we have 2 seconds and 6 seconds.
So let's see here.
Rainbow Seal Girl.
We'll do a T chart. So this one is going to be Rainbow Seal Girl.
Just do R. Rainbow. Your handwriting is so beautiful.
I don't even know if they can see that, but I'll try. And then Dr. Okay, yes?
Yeah.
All right, so for trial 1, we will write down the time.
It was 2. Thank you very much.
Let's do it again. Okay, and ready, begin.
3.
Whoa, that was 3.14 seconds, folks, for you guys listening at home. Hey, 3.14 sounds really familiar. 3.14.
Pi.
Yes, what a lucky number. You might just win this one with 3.14 seconds. Should we do one more trial?
2.
Okay.
3 for each creation.
Okay. Go for it.
A.
What? Oh, okay.
Reset.
And on your mark, get set, go. 3.99. Oh my gosh.
So close to 4.
3.99 seconds. All right, one more.
Reset.
And on your mark, get set, go.
3. All of them in 3.
3 seconds. And what was the name of that one? Did we name that one?
No.
Okay, that's no name.
No, I don't want to name it no name.
Oh, what is it? What's its name?
The green bug. No, the green frog. It kind of looks like a frog.
Okay, so that was for the green frog.
the green frog. It kind of looks like a frog if you
Okay.
think about it.
Is it my turn?
Yes. No, it's my turn. Remember, we each have 2.
Oh, okay.
Still my turn.
Okay. All right. Are you guys ready at home? I hope you're having a fun time building and testing out your tops. Go for it. And go. 4.12 seconds. All right, trial number 2.
I'm like, yeah, you're already forgetting about it. Just like,
On your mark,
you.
get set, go. Oh, that one's gonna go for a long time, but it fell off. So, should I count that one?
Yeah.
Okay.
It's only
2.21
fair.
seconds. Okay. Oh.
I'm just like, I'm waiting for you to do it this time.
Okay. Go for it.
You forgot the timer!
Oh, and it was going so good. Okay. On your mark, get set, go. I bet, I don't think these are accurate because I bet it can go longer. Should we do it on the floor?
No.
Are you sure?
Yes.
Then it won't fall off a table.
Fine, we can do it on the floor. But then we have to move all our cameras and all.
Okay, never mind. We'll just make an average. Yeah, we will make an average. Okay, my turn?
Yes, let's switch seats.
Okay. So far, are we switching seats?
Yeah,
Okay.
I can do the timer and stuff.
Okay. And you'll take the data?
Yes.
All right.
Oh, wait, I need to name this one. The patch of grass.
Patch of grass.
I'm just doing things.
So far, we have Rainbow Seal Girl had the green frog spinning top, and I hope that doesn't fall on the ground. The green frog spinning top, and we did 3 trials and timed how long it spinned before
Patch of
gravity
grass.
took it over. And then the next one was called Patch of Grass, and again we did 3 trials, and we timed how long it would spin before gravity took over. It's really a battle between 2 forces. What forces are we talking about? The 2 forces? Do you remember?
No.
The force of gravity. What 2 forces are we talking about? Rainbow Seal Girl?
Right. Gravity.
And?
Hey, why don't you say it? Angular momentum.
Angular momentum. All right. Can I do a couple of trial spins?
Yes.
Okay.
All right. And.
Wait, no, just to get my
No.
spinning angle going.
Fine.
Okay. Ready?
Go.
Oh, it keeps falling off. It's not fair. Oh, I really think if you are at home and you're trying this, I suggest not doing it on a table, doing it on the ground to get the most accurate results. Okay.
Go.
It's a bad spin.
No, I need to reset.
Oh, what happened? Oh, 5 seconds.
No, I need to reset.
Okay,
I was accidentally pressing lap.
Oh, okay. We'll do it again.
Okay. Go. No.
3.91.
No, I keep on pressing
What is
lap.
going on? Oh my gosh. Okay.
One
That's
more
all right.
time.
We'll give you. That's okay. Data recording is an actual job. That's a big deal.
Oh.
So we'll give you time. Go ahead. Shall we?
Go.
No, that doesn't count.
That does.
No, that doesn't count.
Yes, it does.
Wait, one more, please. People at home,
No.
does that count? I totally messed up on my spin. I should get a redo.
That does not count.
I vote for redo.
I vote for not count.
Oh my gosh. Okay, fine.
Yay!
Last
Wait.
So our data might not accurately represent
An
anything,
average?
but we're having
Actually,
fun.
I think my average might be in the 3s.
We're gonna calculate that.
All right, now wait. Go.
Oh yes!
I accidentally pressed laugh again.
That was such a good spin. Oh how did you miss that one? It was such a good spin. Okay, I'll try it again.
Sorry.
Are you ready?
Go.
Oh wait, ready?
Wait.
Okay, you let me know when.
Go.
This is a bad spin.
Sorry.
This guy totally has the potential to do better, but there's some variables that have to really, really come through in order for it to win. Battle gravity versus angular momentum.
What was this called?
Oh, I think I called it a hat.
I'm just gonna say hat.
Okay, are we ready to do my next one? All right, this is just so you guys can see the difference here. This one definitely takes up more area. It's bigger.
Our sample.
This one is
That's gonna do really good.
This one's maybe gonna do really good because we made this one ahead of time. Don't tell anybody. Okay.
We made this one ahead of time.
Oh, okay, yeah, we did make this one ahead of time and we practiced it, but still, there's some variables.
Oops.
There's some variables that.
Go.
Oh, okay.
No, go.
The technique of the spinner, I'm finding, has a very large impact on how successful the top spins. I wonder if any of you guys are experiencing this at home. Ready? Tell me when.
Go.
I broke it.
Oh, okay. That doesn't count.
I broke it.
That doesn't count.
Okay. Ready?
Go.
You gotta get again. Data recording. Error.
Reset.
Okay. And wait. And wait.
Stop!
And wait. Okay. You tell me when.
Go. No! Well, good thing it doesn't count because I keep on pressing left.
Right. Hard.
I can't get it right either.
Okay. Here we go. We got this. Should we take a breather?
Let's go.
Okay.
Go.
Oh, I did a good one.
3.
Okay, nice.
3.9. Oh, 9. Oops.
Okay. And
Reset.
Go. Okay.
2.77.
The spinning technique is super important, I'm learning.
All right.
Okay. So now we're going to have to calculate the averages. Let me just show them our data table real quick, and then we'll go into the calculator and calculate our averages. So this is a data table. Yeah, we just made it quick and easy with a little T-chart on one side. Oh, she's ready to assess the data. So in order to get an average, we are going to add up a sum of all of them and then divide it by the number of times we tested it. So let's see what your average is. 3.14 plus what?
3.99.
3.99 plus what?
3.03.
3.03.
Plus.
And then divided by 3. Your average for the green frog is 3.39. 3.39. That's just for this guy right here.
How does it sort for average?
I don't know what this AVG.
Average.
For the green frog is 3.39.
This is GF. I don't know. GF. Average GF.
3.39. Ooh, bless ya.
Thank you. That's 3.3866666.
Well, yes, but I rounded it. So this is 3.386, but because that's a 6, I rounded the hundredths place up 1. So it's 3.39.
3.39.
Awesome. Now let's do the average for the patch of grass spinning top. The average for the patch of grass
It says
spinning
PG.
top.
Now
We've got 4.12 plus what?
2.21. And then 2.92.
We're going to divide that by 3 because we took 3 measurements. It's exactly 3.
Wait.
Yeah.
Did you press the equal sign?
Yeah. 3 seconds. The average for the patch of grass is 3 seconds. The average time of spin. Okay.
There's a G right there.
Can we do mine now?
Yes. I can now. Should we switch seats again?
Oh, sure.
You get to write all the averages and stuff because I want to do this math.
Okay. Did you hear that, parents? Sometimes I want to record things. She just said, I want to do this math. Hello. That's what we're talking about. Playful learning and engagement in science, math, engineering, tech, everything.
2.25
Oh, I'll read them out for you. 2.25 plus 1.69. There you go.
Wait, so what do I do?
2.25. Now plus sign. There we go.
But it goes to that. What?
What is going on here? What's going on here? Let's see here. 2.25 plus, then put in 1.69 plus 2.94 equals. Okay, now we're going to divide that by 3. 2.29. So I've got my average for my, what was I calling it?
The hat.
Hat.
Just do.
And what was the number?
2.29.
Okay. Okay, yeah, it's a little lower, but maybe my next one's gonna crank it up. Now for my. All right, everybody, welcome back. We figured out our technical difficulties and we're back. Just a reminder for those of you guys that are just joining us or maybe logging on, I'm Dr. Dijanna, Deep Ocean Doctor, and I'm here with
Rainbow Seal Girl.
And we're here for our creative Playful Learning Hour, brought to you by Vans with the 2-Bit Circus Foundation. And what are we making today?
Spinning tops.
Spinning tops.
But I just have to say something. Last time you told me to make something that was blue, and I realized that every single thing I'm wearing on is blue.
Because blue is a great color on you.
Also on you.
Oh, thanks.
Even though you're not wearing on any blue other than your glasses.
Well, gotta keep a little style there. All right, you guys. So what we did is we made a bunch of different Lego versions of a spinning top. Here's one. This one was called the hat top right here.
The hat.
I'll go ahead and place that in this guy right here. And then this one I called the red flower top. We went ahead and we had I tested this one. We tried that one.
I made mine from scratch.
And what was that one called?
Meadow, I think. Something
like that.
Grass patch. Grass patch.
This one was the grass patch.
And then that one was the green frog. Let me explain to you why I named it that, because if you really think about it, it kind of looks like a frog without these three little things. Don't you think?
Cool.
Frog.
It kind of does. I like it. So we did a spinning top battle. Would you call it a battle?
Won.
Well, we used data. So we were practicing our skills of being scientists, and we made a data sheet and we collected data to determine how long our spinning tops could actually spin before being overcome with what?
Gravity.
Yes, before being overcome with gravity. It turns out we did some very complicated math here. You see that? Yeah. And we calculated the average time it took for our spinning tops to be overcome by gravity. The average time for the green frog was what?
3.3.
3.3 seconds. The average time and the green frog reminder. Oh, it's this one. This one's the green frog. Everybody back home. And the average time for the patch of grass was
just 3.
3 right here, this one. And then
yours.
Mine, well, we had some issues. My averages were 2.29 seconds and 2.6. So what we're gonna do now is we're gonna build some more, and then let's make a prediction. What do you think would happen if I increased the length of my top, like by doubling it?
I don't know.
Do you think it's gonna work better or fall over?
Probably fall over because it's heavy.
All right. I am going to take the ones that I already made and I am going to make them longer. Okay?
Look what I made.
Them longer. Nice.
I have no idea what that is.
I don't know what that is either, but it's kind of cool. All right, so let's see here. I'm going to take this guy and I'm going to make it longer.
You know what? I'm just going to do this. Simple addition.
Are you going to add to yours the one that, oh my goodness, the ones that you already have? All right, so if you look here, I've got loads and loads of red bricks, and I'm gonna take my initial one
Legos.
and make it. It even sounded like it was raining Legos. It rains Legos a lot.
I made an extra long top.
Ooh, can you describe that and show that? That's
so
really
all
cool.
I did was really
make sure they can see.
All I did really was just connect each of them together. Now let's see how this thing works. surprisingly still pretty good.
It's still raining Legos in here.
Oh my gosh.
It worked so good it fell on the ground and broke. That's all right. While you pick up those pieces, I will show this one. So I decided
Make sure it
to
doesn't rain Legos on me.
make the original top a little longer. My idea was that it was going to make it easier for me to spin. Oh.
Looks like I was right.
Why do you think it's falling down so quickly?
Let me show you. The power of the brain.
Oh, the power of the brain. The
I
power of the brain.
need the bigger camera, please. So, the reason why it's falling down is because when you spin it, once you let go, it's most likely just gonna, because this is really long. So like, look, we take off the tip of this, it's gonna stay down because there is no thing. But let's make something that would make it off balance.
Oh, we're gonna explore with balance right now. I like that. That's kind of cool.
That doesn't make it off balance. You know, this thing. Oh my gosh.
I want to put you in this seat so that they can see what you're working on, because I think you have a really good idea about balance. So I'm going to get out of your way. I want you to come here, and I want you to show them what you're working on about balance.
All right. So maybe I should change the cameras. Okay, now you can see me much better.
That one doesn't have sound.
Yes, it does. So for this thing, are you absolutely sure it doesn't have sound? So for this, since it's taller, it's just simply gonna tip over since I let go of it. Since it's already off balance with this thing, so when I spin it right here, look, it just topples over because it's too tall. But when it only had two, look at the difference. It could actually at least spin for a little bit. So that is why you use the power of your brain. Applause.
If only we had sound effects. Applause. The power of the brain. The power of the brain. Well done. Well done.
So that's why it didn't work.
Balance is important then. So not just the speed and how much it weighs, but you also need to make sure it's well balanced. So it's still too heavy on the top.
I have an idea. What if we did only one block instead?
Try that.
This is crazy.
I'm going to try one block too on this guy.
Yeah,
nice.
Much better.
Nice. The balance thing really makes a difference. All right, let me try this one. You putting yours back together?
I think this honestly looks more like a temple when both of them are
I like it. I think we're almost ready for our final battle.
Oh, really?
Yes.
When they have to be connected together.
Yes.
And we only get one time to do it.
Yes. Well, no, we should do 3 because it's science. Oh, that one's nice. Okay.
That looks really beautiful.
So now I almost want to hey, can you spin it? I'm going to do slow motion.
Okay.
Ready?
Both of ours?
Spin one. I'll move this out of the way. It looked really cool, you guys. If you have an iPhone at home, go ahead and slow-mo it.
All right.
1, 2, 3. All right, let's see what it looks
Before
like.
it falls over.
I'll play it one more time for you guys back at home, too. It's so funny. Whoa, that was so cool.
Let me see. If you can see. Then just like, oh wow.
That's cool. Can you do the other one? Let's get a slow-mo of it, and then we'll do the final battle.
Alright, battle that I actually have no idea who's gonna win.
I don't either. I mean, if you look at them, you can make some predictions. Think about mass, how heavy they are. Think about how balanced they are.
I actually think that mine might win again because look how balanced this is.
It's pretty balanced. Okay.
And like yours.
Slow-mo ready.
And this guy.
And action. Okay, that one was a little.
Wait, show that again.
Show you again or show the
viewers?
Oops, this one. Yeah, that one didn't go as well. But all right, let's do some data.
Now the final battle.
The final battle. Ladies and gentlemen, boys and girls, everyone who happens to be watching this stream and joining us for the battle of the Lego.
And then after
Spinning
we're all going to
tops.
rejoice together.
Yes, it'll be fun.
Unless I win, of course. Or you win.
I mean, we're all learning, so I'm going to say we're both winning.
I actually kind of want to know which team everybody voted.
Well, we'll have to check that post. All right. Are you ready? You're going to go first. Timer activated. Oh, no, that was camera.
Oh,
Timer
God.
activated. Nope, yes.
Stopwatch.
Clear, and on your mark. Get set. Are you ready?
Yes.
Are you sure?
Yes.
Are you sure?
Yes.
Go. 2
So it wasn't accessible
70
together.
seconds.
Ah, so it wasn't that accessible
Well,
together.
we increased the mass and the area,
True.
and that might have had an impact
No, we
on
didn't increase
how
the area.
affection. Well, I think we did.
Sort of. I mean, that.
What is the definition of area? We talked about this one here.
Area and perimeter. The only thing that was 4 blocks. That's the only thing that increased the area for
Well,
me.
we might have increased it a little bit. Are you
For
ready?
you, definitely.
Oh, Zia. I'm sorry, Rainbow Silk Girl. Will you time me?
I thought we were doing 3.
Oh, okay.
I'm just like,
On your mark. Get set. And go. 3.02 seconds. All right, one more time. On your mark. Get set. Go. Oh,
Oops.
redo?
Yes. Did you laugh?
Yeah. On your mark. Get set. Go. 2.29.
I think I'm starting to get into your league.
My league? We'll see. All right. Well done. Well done. Yes. Not too bad. Now it's time for us to do the other one.
Let's switch seats again.
Switching seats.
Switching seats. Switching seats. Go! Alright.
All right.
Now,
I'm going to clear the area.
are you ready?
Nope. Area is not. Area is not cleared. Area is now clear, obviously.
Ready.
Yes.
Set. Are you absolutely sure you're ready?
I'm sure.
Go! 1 point.
Woo! Okay, ready?
Set. Go. 3.72.
Oh, well done. Well done.
Why are you saying well done to yourself?
Oh,
Well done to
it's
you.
called self-efficacy. I mean, I'm
Never heard of that.
believing in myself.
Go.
And
Stop.
Oh, okay.
I accidentally did like a bunch of blocks.
Oh, okay. Let's go again.
Go.
Not bad, not bad. Now, are we taking the average again? Should I open up the... You're gonna need my code.
No.
You got it?
I
All right, oops, we're gonna be taking the average again. All right, while Rainbow
Clear.
Silk Girl works
I already
tirelessly
have.
on the math, I'm trying to put this guy back together for you. Again,
I have to do the math by myself.
these are the two tops.
All right, you keep on working. So
These are the two tops. And while you do the math and figure out what the final results are, I'm just going to review. I'm just going to review the science behind what we're doing. So it's been really fun. We're building things. We're doing different iterations of making spinning tops out of Legos. It's been kind of fun. Some of them work. Some of them we could probably improve and play around with them. And I bet you we will for the rest of the day today. But I wanted to remind you of a little bit of the science behind it. Like if you have an actual spin top, they spin for a long time. Why is it that they spin? Now to remind you what we talked
this
about
was
in the beginning.
your average.
Okay. They spin because of science, physics. Yes, Newton's first law states an object in motion will remain in motion unless acted on by an outside force. That means if I have a Hot Wheels car and I push it, that car is going to keep going and going and going until an outside force like gravity or friction stops it. Okay, an outside force like gravity or friction stops it. Newton's first law. We're observing it. Check out this guy. He's going to spin and stay in motion until it's acted on by the outside force, which is gravity. Okay, gravity sends that guy down to the ground. Kind of cool. But in addition to gravity, there's something else we need to think about.
No.
Because objects that spin experience
Wow, I'm
something called
surprised.
angular momentum.
I'm not sure if it's correct, is it?
Good math. That's a surprising
hold on.
result.
I'm not sure if it's
We're
correct.
gonna redo it, and we're gonna revisit the
Wasn't
math.
this
at the very end.
that was yours?
Oh, yeah.
It's correct?
Yeah, redo it, and we'll revisit the math at the end.
Hey, I already did it though.
Angular momentum. It's what you see when an object spins around. So if an object is spinning, it's going to want to keep spinning until an outside force acts upon it. Now, there's ways to increase and decrease that angular momentum. It depends on the size, the mass of the object, and how fast it spins.
All right.
So at the end of the day, we were basically experimenting
Gravity,
versus,
angular momentum.
yes. So if the spinning top stops and falls to the ground, who wins?
Gravity,
And if the spinning top moves and continues to spin, who's winning?
angular momentum.
Angular momentum. So
But
at the end,
This
we have
is
some
the
really cool
game
science words.
results. Can you even see it?
No, we'll have to
then
say
I'll
them
read
out
it.
loud.
So,
Oh,
for-
wait. Let me show them so that they know what we're talking
I'm
about.
gonna call that the frog meadow.
Okay.
So for the frog meadow,
This one right here.
yes, the first roll, 2.70 seconds. Second, 3.02 seconds. Third, 2.29 seconds. Average, 2.67 seconds.
All right.
Now
2.67.
for your thing. Your thing. I don't know what it's called.
The thing.
First round, 1.75 seconds. Second, 3.72 seconds. Third, 2.68 seconds. Average, 2.07, surprisingly.
So the winner for our top brick challenge.
Congratulations.
Really?
No.
Oh, who's the winner?
Me, look at the average.
Oh yes, if we look at the numbers and follow the data, congratulations, dun da da dum. Yes, she won.
Now
Cool.
I'll bring you some cake later.
Thank you. Cake sounds good. Some things I'm observing, mine is much heavier than yours is.
Let me.
And mass definitely has an impact. Do you see the difference?
Yeah.
Yeah, and so if something's heavier, do you think gravity is going to act more on something that's heavier
Yeah,
or
since
less?
I don't know, since you're older, most likely, when you don't jump as high as me.
Yeah, that is true. That is true. Okay, I don't know what to say about that one.
Unless like, I don't know, you've been exercising a lot or something, or like you can just jump high.
Okay, but right now I don't have the superpower to defy gravity, which is kind of cool. So you guys can experiment at home with all sorts of different spin tops and all sorts of different, like make them big, make them small, make them tall, make them long. It should be really, really fun. Oh, we should do our song. Okay.
Yes, our incomplete song.
Our incomplete song. So we thought about while we were kind of playing around with spin tops, we came up with like, how cool would it be if we made a song about the spinning top?
Or do you think there's like a video that we could use that's already made?
No, we're making our own. We are creators, content creators.
All right.
All right, so we need to put in things like, let's put down the words we want to
Wait,
include
no.
in the song.
Why don't we do the words that we already have?
I don't remember them.
Okay, then I'm out of here.
Okay, we want spinning top,
No, that's fine. We don't need to write them down.
and we need Newton's law and gravity.
Yeah, and usually it takes you days to
And
figure out a single
angular
verse.
momentum. Okay, we can do this in 2 minutes.
We can't.
Today's activity was called Top Brick. We learned about Newton's laws and we hope they stick. Oh! Okay, now you do the next verse. And the next line.
When gravity wins, it goes toppling down.
I like it.
Oh.
When gravity wins.
Don't write it down.
I have to, I don't remember.
Never
Topples
mind. When gravity wins,
down.
don't write it down.
Okay. What did mine say? Oh, today's activity was called Top Brick. We hope the science you learned will stick. When gravity wins.
You change the lyrics.
That happens sometimes. When gravity wins, it topples down.
When angular motion.
It spins to the ground. Oh, angular motion. It keeps spinning to the ground. Angular motion.
Because it's true. It doesn't.
Keeps spinning.
It actually does keep on spinning to the ground.
To the
Like when I
ground.
spin it, it always goes.
Yeah. See, this is okay.
It keeps
All right.
spinning. Wait.
Okay.
It keeps spinning to the ground. Top brick goes on and on and on until the gravity makes it go gone.
Oh, top brick goes on and on
And on and on. That's a lot of
till gravity does what?
makes it fall down.
Till
or
gravity
something.
makes it fall down. Okay.
Oh.
Let's see how it goes. Today's activity was called Top
Top
Brick.
Brick.
We learned about science.
No,
We
no,
hope
it's
that
a-
it sticks.
No, say it again.
Today's activity was called Top Brick.
We hope that Newton's law.
Oh, we hope that Newton's laws stick.
Newton's laws will stick.
Okay. Today's activity was called Top
Top
Brick.
Brick.
We hope that Newton's laws will stick.
When gravity wins, it topples down. With angular motion, it keeps on spinning to the ground.
Top Brick goes on and on and on.
Till gravity makes it fall to the ground.
Down.
Fall down. Yeah, I don't know.
We're doing pretty good here. All right.
I guess.
Well, you need one more line. So far we got today's activity was called Top Brick.
We had so much fun, but we don't want to.
Quit.
Yes.
Okay, that's the last one.
We have so much fun, so we don't want to quit.
Okay, I think we got it. Okay.
Now let's sing it. You do the first verse.
Okay. I'm going to change it to science. I just think science works better. Is that okay? Thanks. All right. Today's activity was called Top Brick. We hope the science you learn does stick.
When gravity wins, it topples down.
Angular motion keeps it spinning around
Top brick goes on and on and on.
till gravity makes it fall down.
Today's activity was so fun, so we don't want to quit until the fun's done.
Oh, that is awesome. Should we do it one more time? You guys like our song? We just made a song about what we did today. Today's activity was called Top Brick. We hope the science you learned will
Stick. When gravity wins, it topples down. With angular motion, it keeps spinning to ground
top bricks go on and on and on and on.
until gravity makes it fall down.
Today's activity was called Top Brick. We had so much fun. We don't want to,
Quit.
but our time is up. So
We have to.
I am Dr. Dijanna, and I'm here with Rainbow Seal Girl. Yes, and we had so much fun. Did we have fun playing with these bricks?
Absolutely.
Yeah, we had fun. We played with bricks. We made things. We learned a little science. We even sang a song, and we also made a mess. Like the entire ground is covered in Legos right now, which is so much fun. But be careful to make sure you walk with your shoes on because Legos do hurt when you walk barefoot. Just saying. Anyhow, thank you so much for joining us. We're with the 2-Bit Circus Foundation, and we can't wait to see you on another hour of playful learning. You have anything you want to say goodbye to the viewers?
Yeah, bye.
All right, that's it. Signing off, and please join us again, same time, same channel. All right, bye everybody.